Okay. Very important is also the fork handler have to be set up. Has to be set up before any locks is acquired, because I will show you one example where this race condition between the fork handler initialization and that some global mutex is already taken. Just yeah, this is important, and how I mentioned, the order of handlers registrations is important too. Wrong order can lead to deadlocks. And very important is that fork and pset at fork uses the one share the lock which protected the at fork handler list. It looks like it's not much important, but I needed to fix it again. This is a picture. This is a picture why it's complicated in libpkcs11. Because pkcs11 is mostly the wrapper, and there is the some slot, and this slot uses dynamically opened the plugins. There is the soft token, which is soft emulation for hardware crypto. There is the kernel, which uses for hardware crypto framework, uses hardware crypto framework to speed up crypto operations. And there is something like meta slot, which is these slots are just only wrappers. You call the functions, and the libpkcs 11 called the same function in this library. It's okay. But in the meta slot is some intelligent slot which say, okay, for this cipher, we use kernel because it's faster, or it's supported, or it's not supported in soft token. Just meta slot usually offers more the union of all providers. And it contains a lot of locks inside as well. And each these three libraries has often at fork handlers. You cannot use one in libpkcs11 because application. Okay, it's not recommended. It's not recommended to link directly to these plugins. It is possible. In some special case, it's necessary. For example, OpenSSL use it for OpenSSL pkcs11 engine. Use it to determine what kernel, what hardware supports, what cipher hardware supports. But it's not recommended. But you can do that. Just you need to have own at fork handler here. 10 minutes. Oh, speed up. Okay, lunch. Okay. Just it's very complicated situation. What happened? If you call the one thread and second thread, it's one of most problem here. Function C initialized setups everything in libpkcs. There is something like global mutex. Okay, mutex lock. There is function pkcs slot mapping. It starts to really open all the plugins, soft token. Calls init sections. Init sections start to register pthread at fork handler at the beginning. But at fork handler, as I mentioned, needs to acquire the at fork list mutex. Okay, second thread, blah blah blah. Do the fork here. Okay, fork needs to acquire at fork list as well, because it needs to go through all at fork handlers or perform all at fork handlers. Call at fork handlers prepare in pkcs11 and okay, because I need to acquire all mutexes before at fork, before fork. Okay, first what I do in at fork handler prepare, I want to take acquire the global mutex, but it's already taken here.
How long does it take to find such a deadlock?
How is the okay? It depends. Usually you can see it's three. At this moment, I am able to. I know how it works. It's 1, 2, 3, 1, 2 hours to find what's going on. But it depends on kind of deadlock. First time I spent no, not first time, but second time I spent 3 days to rethinking all ordering of at fork handler registering order and how to do that correctly. Yeah, because this is very. I never expected something like this. Yeah, just I can show you this some demo here. Pick up. Oh, VirtualBox. Okay. Press it. Okay. Just let me show what I did here. This is left side. It's original code. It's mostly fixed, but the right side is what I changed. For example, there the previous the problem for example with at4 handler is that you cannot acquire mutexes which is not already initialized. You need something like this to verify. Okay, I'm already initialized. I can acquire the mutexes. On the left side, it was done in the C initials functions. 5 minutes. Okay. In C initialize functions at the end of library initializations, but the global mutex was not protected here because it's you could see that there is the global mutex taken in C initializations. It was race condition. And it was one important fix, and second fix is here, just the reinitializations of the mutex, because I cannot to fix the deadlock, which I showed previously. I needed to reinitialize the mutex. The problem is this: is that it's not standardized. The POSIX standard doesn't define how to do that. It works because I looked into the libc source code and says, okay, it looks like I test it and I check the source code of libc and it works. But it works because at this moment it's not standard. Yeah. We can okay. I need to run it twice every time. Nice tool. Just yep. CD demo. Okay, I have a lot of things here. One is the fork init hang. It's what I run it. What's this? Okay. Just another example. It worked. Yeah, there is some. Okay. I run repeatedly some I think 10 threads. Each do some signatures, and I parallelly do fork in the loop. Just you can see should not be there defunct because okay. You should see some grep fork. Okay. There is a different timing here. It's not a problem to simulate it on the bare metal, but in the VirtualBox it works more better. Just okay. Not that. We can wait for a few seconds. On bare metal, you usually in 10 seconds get a lot of hanging process. Another RC4 crash. It's another problem. It's not at fork handler, but you can see that the application crashed very fast. It's problem that the session. I will talk. Oh, I will not talk probably. But its sessions use parallelly from two different threads. The session contains the state information, and if you call it from two different threads, it's usually kill or remove some, reset some information. So, just this you can see this in some Java version because. For some reason, I got email yesterday. This was for I think for escalations, which says, okay, we have this tag. Fix PKCS11 library. I see. Oh, it's not problem with PKCS11. It's problem with Java, Java crypto framework, which calls which share one session in two different threads. Okay, I try this. Just no. Yeah. It's here. Okay. You can see the second process here. If I do MDB, not. Okay, it's difficult to run it in the VirtualBox because the race condition is very small. And probably the timing here is and process switching in the VirtualBox it's not so fast, or thread switching. Just okay. Sorry. In the latest version of Nevada, it's already fixed. It's the reason why I take VirtualBox. Show you this. Okay. 0? No, just
-3.
Okay. There is some parallel memory access which I already described in the piece, the paper. I recommend to you to look into atomic.h functions and this man pages which describe how to atomic operation works and why to need to membar operations. And I put some extra information about thread local storage. If you need to have some thread-specific local storage, which is visible in all functions, like local global thread storage. Just there is some methods, and also there is compiler-specific syntactic sugar for it. And also there is some mention about sessions. Okay, so I would like to thanks to Julius Strofek and Chris Bill, who reads my paper and give me some feedbacks, and of course German user group for this conference. Just